Plastic. Water bottles, juice bottles, food packaging, all going into my recycling bin. We do this every week, sorting our rubbish for recycling. But how much can get recycled and remade into new PET, polyethylene terephthalate? I know that the collected PET plastic can be processed and melted down to make new bottles, but there are only a handful of times the same plastic can be melted and reformed before it loses its quality. So how can the cycle of PET plastic be improved? I've been invited by Nestlé Waters to hear about some of the research they and their scientific partners are working on.
The innovative idea of Carbios was to use enzymes to fully break down any kind of post-consumer PET plastics into their original building blocks and to produce new bottles and packaging. It is the first biological approach to enable PET plastic to be recycled infinitely.
Infinite recycling of plastic. Can all PET really be recycled again and again? Professor Alain MARTY is a leading expert in enzyme research and is the Chief Scientific Officer at Carbios, a green chemistry research company based in France. Working with Nestlé Waters, Professor MARTY and Carbios are using enzymes to make plastic recycling a virtuous circle. First, though, how does he see the recycling problem?
During the last decades, industry has produced and we have consumed tons of plastics. And the reason is very simple. Plastic is the magical material that can take various forms: solid, flexible, elastic, leading to a huge number of applications to protect and store food, to lighten cars, to consume less fuel and produce less CO2, etc. Then the problem is not the plastic, it is the pollution by plastics. I think nowadays it is no more acceptable for the society and for consumer without taking care of the end of life of plastics. In Western countries, things have improved and the system of collection, even if it is not perfect, is better organized. The next step is to develop processes to infinitely recycle this plastic, and my dream is that Carbios becomes a leader in this circular economy.
Can you tell me what Carbios has been doing to solve this problem of recycling plastic?
If I take the analogy with a pearl necklace, to make a plastic it is necessary to assemble pearls, 2 pearls in the case of PET. These pearls are the building blocks of the plastic that we called monomers, and that nowadays are produced from oil. The innovative idea of Carbios was to use enzymes to fully break down any kind of post-consumer PET plastics into their original building blocks, the 2 monomers, which are terephthalic acid and monoethylene glycol.
And how does that process work?
Our enzyme, like a molecular scissor, breaks down the link between the 2 pearls, the monomers, and liberates them. After purification, these 2 monomers can then be used again to produce PET plastics equivalent to the virgin ones, and to produce new bottles and packaging. Then it is the first biological approach to enable PET plastic to be recycled infinitely.
What are enzymes and what do they do?
An enzyme is a protein invented by nature to realize very efficiently all the reactions necessary for the life. In each of our cells, thousands of enzymes are working together for instance, degrade food, produce energy, to move and think, build and repair our tissue, etc.
So you have taken a natural enzyme and developed it and improved it so it will eat away at the component parts of the plastic bottle.
Nature did not already design enzymes for the depolymerization of plastics. It is by accident that we discover an enzyme able to degrade the PET, but this enzyme was not really efficient. Our work, in collaboration with my colleagues of the Biotechnology Institute in Toulouse, was to fully redesign the active site of the enzyme in order to obtain a very efficient scissor for PET.
So it opens up the possibility of infinite recycling of plastic.
Yes, with this technology, it is perfectly possible to recycle infinitely the plastic.
This feels like a major shift in how we recycle plastic. It feels like a revolution.
Yes, we can say that it is a revolution because thermomechanical process is the only way not to really recycle plastic. It is only reuse of the plastic. In this thermomechanical process, bottles are just melt, grind, and reused mixed with PET produced from oil. During the melting process, the polymer chains are broken, and consequently, the mechanical properties of the plastic are altered. Then it is only a way to reuse several times the plastic. In consequence, it is not a true solution for the end of life of plastic. On the contrary, the process developed by Carbios is a true circular economy. From the plastic waste, we come back to the building blocks and we are able to produce a plastic with exactly the same properties. A tray or colored shirt can be recycled in a clear bottle, and the contrary is also possible.
Carbios is working with Nestlé Waters to make this a possibility that plastic bottles can be recycled infinitely, and there is a much greater incentive for us to recycle in a sensible manner. What is the challenge that Carbios and Nestlé Waters have going forward to make this on an industrial scale?
First, I have to say that it was a great honor that a prestigious company like Nestle is interested in our technology. But it is also a proof that our technology had an industrial and economic future. It is crucial for Carbios that a plastic end user like Nestle produce at industrial scale and test bottles made with our recycled PET. It fully validates our technology and it will accelerate the technology commercial readiness and bring it at full industrial scale. It is also important that they support us to structure the industrial value chain from the waste manager to the PET producer.
Is this already available to roll out on an industrial scale, or is this still in the development process?
The technology we develop is currently running at pilot stage, and Carbios has already produced the first recycled PET bottles that were tested by Nestle very recently. And we are building an industrial demonstration plant, and this one will be in operation beginning of the next year to recycle post-consumer PET plastic, but also polyester fibers. With this demonstration plant, we will produce 100 tons of PET, and this 100 tons of PET will be an opportunity for Nestle and other big companies to test this product and check that it corresponds perfectly to their requirements. Our technology is designed as an industrial solution that keeps unchanged existing PET production facilities. It only requires the addition of a depolymerization unit, breaking down post-consumer PET plastics and polyester fibers into their original building blocks. By keeping current PET polymerization facility unchanged, this technology has the potential to be deployed globally under the world.
The traditional methods of recycling plastic seem to be quite inefficient, but there seems to be a much greater efficiency with what Carbios has developed as a method of recycling plastic.
The main advantage of an enzyme is that an enzyme is very selective. This enzyme is designed to degrade PET and is not able to degrade other polymers like PVC or polyethylene. And then one advantage of this process is that it doesn't necessitate an intensive sorting at the entrance. The PET can be mixed with other polymers. With this technology, plastic waste becomes a resource to produce new plastics. Of course, at the end, the objective is to reduce the quantity of waste.
So, what next then for Carbios and for Nestlé Waters? Where do you imagine this partnership heading?
We collaborate with Nestle on the recycling of PET, and PET represents 70 million tons of plastic produced each year. and roughly 20 million are dedicated to bottles and packaging, but 50 million to textile. In this field, PET is called polyester, and it is the main fiber used in the textile industry. Our enzymatic technology addresses both fields, and the deployment of this technology to fibers is running now. Of course, we don't want to stop with the PET process. Carbios is also working on new projects to make biodegradable or to develop new enzymes and processes to recycle new plastics. For instance, we develop a process to make PLA, which is a very promising bioplastic, biodegradable and compostable at room temperature. It is done by introducing an enzyme inside the plastic to ensure its degradation after use. And it could be an efficient solution to replace polystyrene, a plastic really difficult to degrade and recycle.
So how do you imagine plastics such as PET will be used and thought about in the coming years?
My dream is that the plastic becomes again fantastic, because plastics present incredible property for a lot of application. To reach this goal, it is necessary that the plastic wastes become a resource to produce new plastics. And with Carbios technology, we can enable PET plastic to be recycled infinitely.
Professor Alain MARTY of Carbios, describing his and Nestlé Water's plan to recycle plastic infinitely. So, the technology is coming, but are we ready to make sure many more of the bottles we use are properly collected and sorted? In the next instalment of Nestlé's Together for Circularity podcast, we'll find out how the process of collecting and sorting the high-value PET bottles makes good business sense as well as being an environmental necessity. If you want to find out more about what Nestlé Waters is doing to move towards a virtuous circle of recycling, please go to nestlewaters.com and click on See What We Do. I'm Alistair Elphick. Thank you for listening to this modulated media production.